In lesson 5.5, we're learning a bunch of different factoring techniques. And then on the back, we're going to solve equations using factoring and the zero product property. So if you look at the top of the notes, the first type of factoring that you should always check for is a GCF. The GCF of 14 and 42 is 14. Both of these have at least one x, and they both have at least two y's. So if we remove that from both terms, we're left with x in the first term and 3y in the second term. Okay, for number 2, again, check for a GCF first. The only thing we could divide all four terms by is 1, so there is no GCF other than 1. So we see 4 terms. 4 terms is usually a clue that it's factoring by grouping. So I'm going to group the first 2 terms together and the second 2 terms together. So from the first group, we can take out 6 and an m. If we do that, we're left with n plus 3. When you do factoring by grouping, the goal is to make the parentheses the same. So if I'm trying to make the second parentheses n plus 3, I need to remove a negative 1. So now the outside goes in parentheses together, and then the second set of parentheses you only write once. You don't write squared. Okay, for number 3, there's a GCF of 2. So I'm going to take out the 2. And now the trinomial inside the parentheses is factorable. If you want to see it done with the x factor, you'd have an 8 on top, a 9 on the bottom, the two numbers to multiply to 8 and add up to 9 are 1 and 8. So we have 2 parentheses x plus 1, x plus 8. Okay, for number 4, 2 terms is usually a sign that it's difference of squares, sum of squares, or sum of cubes. This is obviously a difference, and both terms are perfect squares. So whenever you have a difference of squares, you take the square root of both, and then one of them is plus and one of them is minus. Now the second set of parentheses is another difference of squares, so I'm going to factor that as well. For number 5, there's a GCF of 2. If we take out 2, we're left with r cubed plus 125 in the parentheses. Okay, so here's how you factor a sum of cubes. Now recall, a sum of squares is not factorable, but a sum of cubes is. When you have a sum of 2 perfect cubes, it always factors to a binomial and a trinomial. And so you figure out what is being cubed. R is being cubed. What's being cubed here? 5. All right. Then you take the first term, which is r, and you square that. Then you take the 5 and you square that and put it in the back. In the middle, you multiply the r and the 5 together to get 5r. And so now the only thing I'm missing is the signs. The way you figure out the signs, you can use an acronym called SOAP. and you use this for sum and difference of cubes. So what that stands for is the first sign is going to be the same as the one you had in the problem. The second sign is going to be the opposite, and the last sign is going to always be plus. So same, opposite, and the last one is always plus. For number 6, that is a difference. There's two terms, so is it difference of squares or difference of cubes? Well, 9 is a perfect square, so we're going to use difference of squares. So square root of 100 is 10. Square root of m to the 8th is m to the 4th. One of them is going to have a plus in between. The other one's going to have a minus in between. Alright, for number 7, there's no GCF. We can try to x factor, but I don't think we can think of two numbers that multiply to 1, but they add up to 1 as well. So it looks like 7 is prime. Okay, on number 8, there's clearly a GCF of C, so I'm going to take out the GCF from everything. C cubed plus C squared minus C minus 1. And now I'm going to do factoring by grouping. And I'm going to change this to brackets just so we could keep the GCF separated from it. Alright, so from the first group, it looks like we could take out C squared. So from this group, I'm going to take out C squared. And so if I take out C squared, I'm left with C plus 1. And the goal is to make the second two terms become C plus 1 as well. So we have to take out a negative 1 from them. So now we can rearrange the bracketed part. So the outside stuff goes together. The inside stuff, you only write it once, you don't square it. So we have a difference of squares here, so I'm going to factor that. If I factor that, it's going to be C plus 1, C minus 1. But we already have a C plus 1, so we now have two of these. On the back, we're doing one extra step. After we factor it, we're going to solve the equation. So if you want to solve, you need to equal the equation to 0. Two terms is a hint that it's difference of squares, difference of cubes, or sum of cubes. So factoring it as a difference of squares, you get that. Now, neither of these can be factored further, so by the zero product property, we know that either the first parentheses equals 0 or the second set equals 0. So if I solve this doing two steps in one, I know that x equals plus or minus I rad 7. So I'll just show the work. X squared equals negative 7. So x equals plus or minus I radical 7. Then over here, x squared equals 7. So x equals plus or minus radical 7. Notice we got 4 answers. And the reason we got 4 answers is because the exponent is 4. Okay, so for number 10, we equal it to 0 again. We can use the x factor for this. The top would be 8, the bottom would be -6, so the numbers would be -2 and -4. The only difference is this is not quadratic, so we put x squared minus 2. The other one is x squared minus 4. So this one I know can still be factored, but I could easily solve that one without factoring it. And the steps didn't say to solve or to factor completely, so I'm just going to solve it now because I can see what the answers are going to be. So the first set, if we move 2 to the other side and then square root, we get plus or minus rad 2. And if we move 4 to the other side and then square root, we get plus or minus 2. And the degree was 4, and we got 4 answers like we were supposed to. Okay, for number 11, we're going to take out the GCF first. So they both have a 3, they both have t squared. So if I remove 3t squared from both of them, we get t to the 4th minus 16. The parentheses represent a difference of squares. Alright, so what would make that 0? T equals 0. What would make this 0? Imagine moving the 4 to the other side. You get -4. Then you square root both sides, plus or minus 2i. Then over here, move the 4 to the other side, it becomes +4. Square root both sides, you get plus or minus 2. So we were supposed to get 6 answers. The reason it looks like we only got 5 is because 0 is a double root here. So 0, plugging in for both of those t's, gives us a double root, and then we have 4 more, so we have a total of 6 roots. So there's 4 from plus or minus 2i and plus or minus 2, and then 0 is a double root. Okay, for number 12, I'm going to introduce a new method called U-substitution. The way you do U-substitution is you look at the middle term. So the middle term is -7x, but you ignore the coefficient of -7. So I look at the middle term, -7x, but I don't want the number. I don't want this -7. So I'm going to say that u is equal to 1 over x. And now what I want to do is square that equation I just wrote. So u squared would be, well, 1 squared is 1, x squared is x squared. So the reason I'm doing this, it makes the quadratic a lot easier to factor and then a lot easier to solve. So if I rewrite the original equation using the letter u instead of the letter x, this we wrote is equivalent to u squared. The middle would become -7 times u, right? Because if we multiplied that by -7, we would get this. And then the plus 12 you keep the same because it doesn't have any variables. Okay, notice how much easier this is to factor now. Solving those, we would get u equals 3 and u equals 4. And so now you just have to change it back. 1 over x equals 3. 1 over x equals 4. And if you do that math, you would get x equals 1/3 or x equals 1/4. Okay, for number 13, we have some really big numbers. We're going to try U-substitution again. So again, look at the middle. We see negative 73x squared, but I don't want the coefficient, so I'm just going to call U x squared. Now I square both of those, so U squared equals x to the fourth, and I rewrite it using U instead of x. So it's going to be 4 times U squared minus 73 times U plus 144 equals 0. Okay, those are really big numbers. And if we're doing the x factor, we're trying to come up with two numbers that multiply to 576, but they add up to negative 73. So we know it has to be two negatives. It has to be two negatives because if the top is positive, then it's either two positives or two negatives, but the bottom being negative means it's two negatives. So I'm looking for two numbers that add up to negative 73 but multiply to 576. So I like to start with easy numbers. So maybe 10 times, now what would make 73? 10 times 63, or I should say negative 10 times negative 63. But that makes 630. So I should probably go a little lower. So what if I try negative 9 times, now I'm trying to get 73, negative 73. So negative 9 times negative 64. And I think that does it. So the numbers are negative 9, negative 64. I divide both of those by 4. This one reduces to negative 16. So my numbers are going to be, or my binomials are going to be 4u minus 9. That's if I do the bottoms up. And u minus 16. Okay, now solve for u. We're going to get two values. U could equal 9 over 4, or u could equal 16. Then change it back to x squared. X squared equals 9 over 4. X squared equals 16. And if we square root both sides, we get four answers. Plus or minus 3 over 2, and plus or minus 4. Okay, for number 14, we can do U substitution again. U would equal the middle without the coefficient. And then if we square both of those, we get m to the sixth. So we're going to get 6 answers for this problem. Rewrite it using the letter u. U squared minus 16 times u plus 64. That's a perfect square trinomial. U minus 8 times u minus 8. So I'm just going to square that. So the only solution for u equals 8. But we have to change it back. So m cubed equals 8. So a lot of people would look at that and think, okay, m equals 2. Well, that's true, but remember, there's supposed to be 3 solutions to this equation. So there's actually 2 complex solutions that you can find by factoring. So if I equal this to 0, that is now a difference of cubes. Remember, a difference of cubes creates a binomial times a trinomial. Figure out what's being cubed. Square the first one. Square the 2. in the middle, you just multiply them together and do SOAP. So the same sign, which was minus from our problem, the opposite sign, and then the last one is always plus. Alright, so if we solve these, we get m equals 2. That's one of our answers. And then over here, this is not factorable, so I could solve it using the quadratic formula or completing the square. So I'm going to try completing the square just because the b value is even. So m squared plus 2m equals -4. If I complete the square, there's a 1 here. Factoring, I get m plus 1 equals -3. M plus 1 squared, that is. M plus 1, if I square root the left, and then plus or minus I rad 3 if I square root the right. And so we have our other solution. It is, this is actually two solutions, plus or minus, well, before the plus or minus, I have to move the 1 to the other side. M equals -1 plus or minus I radical 3. Alright, so right now it looks like we only found 3 solutions and there should have been 6. But the reason that happened was because this was squared. So we found 3 solutions from that, but all of these are double roots. So we found 3 solutions from this equation, and then that equation occurs twice. So we found 3 roots and they're all double roots, so we really found 6 roots. Okay, for number 15, we use U-substitution again. Look at the middle, but don't take the coefficient. So U would equal radical x. When you square radical x, you just get regular x. Rewriting it, we get U squared minus 10u plus 21 equals 0. Factoring looks pretty easy. U minus 3, U minus 7. So U equals 3 or U equals 7. Changing it back. Radical x could equal 3 or radical x could equal 7. So that would make x equal either 9 or 49 if we square both sides. For number 16, U would equal x to the power 1/3. Squaring both sides, U squared equals x to the 2/3. Rewriting it, U squared minus 5u plus 6 equals 0. U minus 3 times U minus 2 equals 0. So U could equal 3 or U could equal 2. Change it back. Cube both sides, you get x equals 27 or x equals 8. Okay, for 17, now they're just asking us to write it in quadratic form. So recall that a quadratic has this form, ax squared plus bx plus c. So the key to doing this is just looking at the middle again. And whatever you see in the middle, that has to end up being squared at the beginning. Okay, so this is quadratic form. We have a coefficient. The 5 would be the a. And then, so you have a coefficient and then something being squared. And then plus 2 times the same something, but not squared this time. And then minus 8. Alright, number 18 is not possible. And in order for you to be able to write it in quadratic form, the exponents have to be double one another. So 8 is not 2 doubled, so that one doesn't work. Alright, number 19 does work. So this is our a value. Then we want something to be squared. So a to the 6th is a cubed squared. And then you want the same thing that's squared, but without the square. Okay, number 20 will work because the exponents are double one another. So we need something squared. X to the 4th squared makes x to the 8th. And we need that same thing, but without the square. On 21, we have our a value, which is 12. And we want x to the 4th to turn into something in parentheses squared. And then you need the parentheses without the square. Okay, if you double 3, you don't get 5. So number 22 is not possible. Okay, for our last problem, they want to know the x coordinates where it crosses the x-axis. So what we do is remember that when you touch the x-axis, your y value is 0. So we're going to plug in 0 for y. And I'm going to move that to the other side. So I plug in 0 for y, or f of x. I'm just going to move that on the right. Right, so I can use the x method if I want, or I can use U-substitution. Let's take a break from U-substitution. So the top would be negative 15, bottom would be negative 2. Numbers are 5, actually negative 5, positive 3. So this is going to be x squared minus 5. X squared plus 3 equals 0. So we're going to get 4 x values, moving the 5 to the other side, and then square rooting both sides. We get plus or minus 5. And then moving the 3 to the other side, and then square rooting both sides, we get plus or minus I radical 3. They said x coordinates of points on the grid, so I don't think these count. So we have our 2 x coordinates. The other 2 were complex. Okay, children, that's all for this lesson. Until next time.